We talk about, the size and the scale of these facilities and completely enamored by the amount of infrastructure that goes into pre-training. But really the opportunity for the CSP community that sits here today is in all the things past that.
There is a very different desire to run an enterprise workload companies rely on than just develop it in the garage.
We're now a power-limited industry.
Okay. So on Tuesday, we were here in kind of an uncomfortable position, I think, because there was so much to be said, but we couldn't say anything, right? Because Uncle Jensen was going to speak that evening, and that is now done. So we are going to share a little bit about what happened on Tuesday and what was announced, but we're going to try to mix in some applicability to service providers, make sure that CSPs understand what that opportunity looks like for them. So to get started, I want to ask my illustrious team here, Bernhard and Simon from NVIDIA. Everybody in our community, in the CSP community, knows that people are trying to get access to GPUs, or more, use AI, maybe is the better way to put that, right? Bernhard, tell us a little bit about what's driving that demand. Why is it crazy right now in the industry?
Yeah, well, to understand what drives computational demand, we might need to understand the three scaling laws, which is, first of all, pre-training scaling, second, post-scaling training, and third, time. Oh, sorry. I will come to that back
Test time
later. Yeah, test time scaling, sorry. Let's start with the pre-training scaling, because I think that's the most obvious. We have more data, bigger models, which leads to bigger large language models at the end. So we need more parameters, which drives bigger GPU demand in terms of GPU memory. We're now even talking about a mixture of experts models where we are in the trillion of parameter range. So here we need definitely even more computational demand as it was before. But second, post-training, I think that's not that obvious, but it will drive even more computational demand. We think it will be around 30x compared to pre-training, because here we're talking about fine-tuning, for example. Most of the customers, they won't need to train a model from scratch anymore in the future. So they just start with an existing foundation model and do the fine-tuning as example, or reinforcement learning. So as I said, here we think about 30x the computational demand compared to pre-training. And the third, it's also called long thinking. Why? We've seen DeepSeek model coming out a few weeks ago. And there was kind of a shocking moment. And we heard, oh, now we need way less computational demand. But that's not true. This is one of the mixture of expert models, which needs a lot of GPU memory. Here we are talking about 680 billion parameters. So we need massive amount of GPU memory to store the model. But long thinking means reasoning models. So we're talking about inferencing. In the past, there were just smaller models which were able to solve easy problems, which didn't take too much inferencing performance. But now the reasoning models, they need to solve bigger problems. And here we think about 100x the computational needs compared to pre-training in the near future.
Yeah, I mean, we talk about this in the data center industry. We talk about the size and the scale of these facilities, and everybody's completely enamored by the amount of infrastructure that goes into pre-training. But really, the opportunity for the CSP community that sits here today is in all the things past that, right? That 30x and 100x that Simon was talking about. Bernhard, why don't you, kind of give us some insights into, as you're talking to customers, in Europe clearly, but around the globe, as you're talking to these customers, what do those opportunities look like for CSPs? Like how can NVIDIA help them in these other sectors past pre-training?
So I think when I started to talk about inferencing a couple of years ago, we talked about very little tiny GPUs, 70 watt, put them in a 30-edge box, and that was good enough, video surveillance.
Yep.
Now, a lot of these agentic AI, all of the stuff we shown, like service agents, all of that stuff, they need to have more computing power. So the problem we see with enterprise customers is, first of all, they want to have the data close to them. They don't want to put it into the public cloud. Sovereignty is important to them. Latency is getting more and more important to them, so they want to have it in a data center close to them. Now, the problem they have is most of their data centers don't have more than 10 kilowatt per rack. And a GPU server with 8 GPUs now will be 12 to 14. So they cannot even fit in one server anymore. And they don't have the people anymore to manage it because it requires a different skill set than managing a normal 2U server to run GPU servers. Because they have more power, they have other stuff, you need to look at it, you need to understand Kubernetes, you need to understand how you manage them. So all of those skill sets are not really available in the enterprise, but I'm pretty sure you guys have it. And I think that's a great opportunity for you, rather than just, oh, I can host you 50 servers and good luck with it, where you can add the value with your expertise to help the customers actually fulfill their mission. Now, for us, we welcome everybody where we can work together to solve a solution, to solve a problem. Because just selling hardware, yes, it's great for the number, but long-term success comes from partnership and how we can work together at scale.
Great. So you mentioned these like little 70-watt GPUs, right? I think everybody kind of graduated in the inference space up to, we kind of walked through them earlier this morning, right? Everybody kind of saw the M40, the P40, the A40, right? Now the L40 and L40S, right? Which NVIDIA pulled out of their back pocket at the last second. Oh, here, check it out, L40S. What's next, Simon, right? What's coming? What was announced on Tuesday to kind of slot in for that type of workload?
Yeah, as the successor for the L40S, we announced this new name, RTX Pro Workstation Edition or Data Center Edition, which makes it not easier to really understand. But what's behind? It's kind of, as I said, successor of L40S. It has double the GPU memory, but the great new feature is that we will also support our MIC architecture, which is a multi-instance GPU. So you can partition a physical GPU into 4 pieces. So once you wouldn't need the full GPU memory for a smaller LLM like Llama 3 8B, for example, you could partition into a MIC instance so that you have 4 times 24 gigabyte of GPU memory, which is kind of a great advantage from my perspective.
Yeah, and I think if you look at that, you can now, previously you run one machine on one L40S, 48 gigabyte at 350, 400 wattage. Now you could theoretically run 4 machines in 600 watt. So NVIDIA RTX Pro 6000 Blackwell Server Edition, getting there, it's not rolling yet. We'll start shipping about Q2. It will be requiring new servers. It's 600 watt per GPU. It doesn't just fit into standard server. But the new servers, the new Turin and the new Intel servers will actually run with that. So talk to your partners, talk to your OEMs to say, hey, can we look at that? Can we get quotes out? So we can actually start working on talking to our customers about it.
It's nice of you guys to help Intel and AMD move some chips, right? So
I think when you look at it from the announcements we did, as everybody here knows, we tried to acquire ARM a few years ago. We have a great technology partnership with them. There is a lot of advantages we have with ARM over x86. We can use our own NVLink protocol to communicate with the CPU. It allows us to scale much bigger and allows us to access the memory a bit better. And Simon can give us a bit of an insight why that means a lot to us. When we announced now NVIDIA DGX Spark, which used to be Project Digits, it was an ARM-based supercomputer for the desk. Now, also what we announced is a workstation together with our OEM partners that is having an ARM-based CPU plus a GPU. So yeah, we love to work with Intel and AMD, but there is baggage that comes with x86. And if we can avoid that for certain workloads, we will.
Absolutely. Simon, maybe that's a great transition, like talking us through the other announcements around Vera Rubin. It's a little bit out in the distance, but maybe give people an idea of why NVIDIA is excited about that technology.
Yeah, well, it's, as we heard already, bigger, better, faster. To be honest, I don't want to talk about all the details from a specs perspective, but it should be pretty clear, as I said, the model sizes are massively increasing, especially with this new mixture of expert type of models, where we're now in the range of, 1.3 trillion parameters, which means GPU memory is key. So from the next generation, we expect 288 gigabyte GPU memory, or the Rubin Ultra will be 1 terabyte of GPU memory per GPU, which is insane. But the same applies to Vera, our next CPU technology. Here we're not doubling the CPU cores, but we're ending up at 88 CPU cores per chip, but at just a power budget of 50 watts. Yeah. Because we need to see or understand, power budget is very important as of now. And Jensen said in the keynote, we're now a power-limited industry.
Yes. Anecdotes from my side in the data center business, right? We are a power-limited industry as a whole, right? As a service provider, and whether you're a data center owner or a service provider that exists inside of data centers, the power budget is difficult in the server, in the rack. The power budget in totality is also very difficult right now. So again, Bernhard was talking about this with enterprises. It's worse for them, right? So this is a place for you to help get some of these enterprise workloads into these next generation architectures. Shifting gears a little bit, I want to talk a little bit about the end-to-end ecosystem and how CSPs can participate along the way. You talked a little bit about, what's the new name, Project Digits?
Spark.
Spark, yeah. So, it's really about getting that developer experience into production, right? Either one of you guys that wants to kind of handle that, I'd love to get your thoughts on how CSPs can be a partner in that journey for enterprises or businesses to get from their workstation development into some type of production.
I think what really, really helps here is everybody has access to an NVIDIA CUDA GPU. Is it a gaming GPU? Is it a workstation GPU? Is it a Project Digits? Is it a Jetson ARM-based robot development platform kit? It's easily affordable. You can buy it everywhere. That makes us very, very different. However, if you start writing your code on a workstation or PC, you need somewhere to scale up. Because at one point in time, if your model size gets too big, there is no consumer card that has it. I think our biggest consumer card today is 48 gigabyte. That gives you probably to a 14B model maximum in terms of memory.
Yep.
Well, yeah, it depends. And DGX Spark, I think if you read through the specs, we now expect, and this is a huge advantage, especially for developers that may not have the easy access to data center GPU just for playing or developing the code. And now having this tiny box with 128 gigabyte of combined GPU memory, you could end up with the 200B model if we talk about FP4, which is supported as a precision from the Blackwell chip.
Yeah, and what we then see, and this is the big issue, we do nurture about 20,000 startups around the world. Lots of them fail, let's be honest. And they don't fail because the technology isn't great. But I had a conversation a few years ago with a company that does in the automotive industry. And they said, oh yeah, we want to buy GeForce for our inferencing because that's what they told us is the best. And we're like, uh-huh. And it's also so much cheaper. It's about half the price of your professional GPU. Uh-huh. And we were like, okay, so how many do you buy? We buy 500. And it's a huge saving for us. Okay, guys. So what do you do when it breaks down? What does a breakdown cost you? Oh, $1 million a day. I'm like, okay, so you're talking to me about saving $500,000 here and a breakdown that naturally fails on a consumer board because it's not designed to run 24/7. Costs you $1 million. Good luck. Took them about 3 months to come around and say, oh, now we have 7 line down days. We probably should replace the hardware because it makes sense. Now, the reason why a lot of them start on consumer because that's what they have access to. But they need people like you to actually help them to run enterprise because there is a very different desire to run an enterprise workload companies rely on than just develop it in the garage.
Yeah, and once you think about doing the pilot into production, that's the step where they need the data center resources. And they won't be able to host most of these in their data centers because there is no power and so on. So I think that's the biggest chance for all of you guys once it comes to the test time scaling, which is AI reasoning, which consumes a lot of computational power in the near future because this AI or agentic AI reasoning models, they will definitely need a lot of compute.
So we're almost out of time. I want to ask each of you, doesn't have to be directed at CSPs, what had you most excited on Tuesday, right? He's up on stage, he's talked for a long time, right? What got you most excited?
I think for me, and it's a very narrow detail, is Jensen went on stage with Blue, a tiny little robot, going on a stage, and for those of you who have been here on Tuesday, where Søren interacted with Albert Einstein on stage, and we met him before, and he was really nervous because you cannot predict an AI what it really answers to you. Imagine you do that with a lifetime robot on a stage with 20,000 people watching you in the hall. Especially, and Simon and I talked about this before, Blue version 1 actually didn't really deliver 2 years ago or 1 year ago. It didn't work. So going on stage with a lifetime robot that interacts with you is something really, really cool because it also shows that technology is evolving and constant retraining will make things better.
Well, for me, as I'm more or less a software guy, it's a bit different. I really like the announcement of our new Dynamo framework, which should really help to scale inferencing at a bigger scale. It's not that easy to understand what's behind this framework, but there are a lot of individual steps to definitely improve inferencing, and it should mitigate the need for a lot of people to improve throughput and latency because this is what will be done from this Dynamo framework. So I'm pretty curious on that one.
Absolutely. I'll go as well. I think Groot was my favorite thing, right? I'm excited about robotics. I think that they're going to play a key role in all of our lives over time. Clearly, the robot is humanoid robots are a big part of that. Super excited about that platform. Really excited about Blackwell Ultra too, or was Rubin Ultra? Rubin Ultra.
Blackwell now, Rubin 2027.
I mean, we have what we're seeing right now, and I think what we saw coming out of X most recently with Grok 3 is that the scaling laws are still intact for now, right? Bigger does mean better for now, hopefully for NVIDIA forever. But, I think that I'm really excited about that. It's going to be hard for the CSPs in the room. This is not easy business. It's going to be difficult. Everything is getting more dense. Power is more scarce. And we have to work together as a community, really, to make all of these solutions that NVIDIA is building come together in real valuable ways for businesses, for consumers. And I know everybody here is up to that challenge. So I'm really excited about everything. Thank you guys so much for listening to us talk for 20 minutes. And I hope you have a great rest of CloudFest and Beer Fest tonight. Thank you.
Thanks.